During brain surgery, neurosurgeons are often faced with a delicate and risky challenge: removing a tumor while preserving the maximum number of living cells that surround it.
We are faced with tumors that infiltrate the brain. Our work is to remove as much of these tumors as possible without affecting the quality of life of the patient. And obviously, to do so, we mustn't damage the neurological functions.
At Université de Sherbrooke, medical imaging specialists are combining their expertise with those of neurosurgeons at the Faculty of Medicine and Health Sciences. Their goal, to optimize the work of surgeons and allow for more precise surgeries. David Fortin describes the case of a patient who has benefited from these new medical imaging techniques.
This patient first consulted a surgeon in Montreal who told her, "Well, listen, I can remove a part of the tumor, but it really is impossible to remove the whole thing." She came to Sherbrooke for a second opinion, and looking at it, we decided that it was potentially possible to remove the whole tumor with certain precautions. One of these precautions was to wake her up during surgery to perform cortical stimulation. The other precaution, and that's where Dr. Descoteaux comes in, was to use his image analysis technique to give us more faithful images than we are used to using. It was the first patient for whom we tried such a technique. We applied it, and I have to say it added a very important aspect to the surgery. It changed the way we operated.
Conventional imaging tools provide information that is often limited to locating a tumor. Through diffusion magnetic resonance imaging, Maxime Descoteaux has developed image processing techniques that can map the neuronal architecture of the brain.
The classical comparison is as if we were looking at cars traveling on a network of roads and highways. This is exactly what we're trying to see with the imaging: how the water molecules follow the connections in the white matter of the brain.
These three-dimensional images reveal the neuronal connectivity between the regions of the brain.
We want to see how a brain tumor can affect the connections within the brain. This we see with diffusion MRI. We are now able to see the holes and the roads that may infiltrate the tumor or deviate around it.
As a neurosurgeon, Professor Fortin's goal is to take advantage of this mapping of the brain to identify affected areas, or inactive ones, in order to avoid sacrificing viable neurons.
The brain is constantly remodeling and rewiring its neurons. When the brain is the victim of a stroke, a tumor, or a lesion, it will rebuild its connections. It will completely abandon neurons that have been damaged. And that's why, when we see a patient with a brain tumor, well, the truth is we don't know how the microarchitecture of this patient has been affected. We have no idea how the rewiring has been done. That is what Dr. Descoteaux and his team have provided us with. How does the brain remodel itself around the tumor? The connections from the affected region or outlying regions, which paths did they choose to bypass the tumor and ultimately continue their jobs? How can we plan our surgical intervention to avoid these critical connections?
The researchers plan to continue their work to refine the experimental techniques and make them clinically available.
The goal is to bring this value-added procedure to the clinic for an easy-to-use technique. Obviously, Maxime and his team have knowledge that we don't have as far as processing and analyzing images. The more precise the pictures are, the more information we have, which means the less risky our surgeries will be.
I must say that it's always been a mission during my PhD and my postdoctoral work to bridge research and the clinic, to bring more mathematically and computer science-oriented imaging techniques into the medical world and to clinical settings. When I arrived in Sherbrooke, it was a blessing to meet Dr. Fortin and start working with him.
In addition to his research, Professor Descoteaux teaches in the Imaging Sciences bachelor's degree in the Computer Science Department of the Science Faculty at Université de Sherbrooke, the only program of its kind in Canada. Recently, a patient who has benefited from its expertise sent an email showing his gratitude towards Professor Descoteaux, Dr. Fortin, and their team.
For a scientist, a mathematician, and a computer scientist, it was phenomenal. It brought tears to my eyes. It was an email that profoundly touched and flattered me. It was the biggest honor that anyone has ever given me in my whole life.